Imagine yourself standing upon a vast shoreline at the hour of dusk, where the gentle waves lap against the sands, carrying with them secrets from the profound depths of the ocean. The final rays of the sun glint and shimmer upon the water, crafting a vivid tableau of life's fragility and grandeur. Now extend that vision outward to encompass the entire cosmos, a boundless ocean of space and time, where the destiny of all things is not a recurring grand explosion or an engulfment by colossal black holes, but an ending stranger than any tale of scientific fiction you have ever encountered. This is no jest or vague conjecture. It is a conclusion derived from rigorous physical calculations, meticulously constructed over decades by scientists, grounded in actual observations from telescopes and subterranean experiments. And whilst we may feel diminutive before such a scale, it is human curiosity that has unveiled these clues, concealed within the light of the sun, the moon, and the twinkling stars upon the nocturnal sky. Allow me to guide you through this journey at a leisurely pace, akin to a river meandering through enigmatic landscapes, where each bend awakens mystery and inquisitiveness. We inhabit a fortunate era, when the cosmos remains replete with luminescence from billions of stars, resembling a lavish banquet of light for which no admission is required. The whispers of cosmic winds murmur through galaxies, and the mental imagery of sparkling stars evokes a sense of warmth, serving as a reminder that life is a fleeting gift amidst the vast darkness. Yet the universe was not born in such vibrancy, nor shall it endure eternally in this manner. Stars, in essence, are transient luxuries of the cosmos, for their primary fuel, hydrogen, was forged only once, in the instant of the universe's birth, approximately 13.8 billion years ago. Thereafter, new hydrogen has scarcely been created, much like a treasure apportioned at the outset and gradually depleted over time. Each star resembles a candle ignited with a fixed quantity of wax, burning steadily until it extinguishes, leaving behind a cold silence. In truth, the life cycle of every star has been predetermined from its inception. In the 1930s, a scientist of Indian origin working in America, named Subramanian Chandrasekhar, made a discovery that reverberated through the scientific community. The ultimate fate of stars is rigidly determined from the moment of their formation. He calculated that what a star ultimately becomes depends not upon its brightness or surrounding environment, but solely upon one factor: its mass. Stars of average size, such as our own sun, will swirl into red giants in their senescence, a process familiar to many, is it not? However, fewer are aware that when the sun transforms into a red giant in approximately 5 billion years, the Earth shall not be immediately devoured. Instead, the intense radiation from the sun will propel the Earth farther outward into an isolated orbit, rendering it a frigid, lifeless planet adrift in obscurity. Subsequently, the sun will gradually expel its outer layers into space, leaving only a diminutive core of extraordinarily high density, termed a white dwarf, a silent relic, emitting a faint glow like the final whisper of an extended narrative. Yet the truly awe-inspiring and terrifying spectacles arise from supermassive stars, possessing masses tens of times that of the sun. In their final moments, they erupt completely, becoming supernovae, unleashing energy surpassing the combined output of all stars within a galaxy. Envision the resounding echo of such an explosion. Though in the vacuum of space there is no sound, but in your mind, it resounds like a tumultuous symphony, shaking the fabric of existence. The cores of some of these colossal stars, during the blast, are compressed in an instant and transmute into neutron stars, celestial bodies where a mere teaspoonful of matter weighs more than 1 billion tons, defying our comprehension. As if the universe were condensing the agony of termination into a diminutive sphere. Even larger stars will give rise to black holes, where the core's density becomes so formidable that it warps space entirely, devouring all in proximity. If one could witness the demise of these stars from a safe distance, it would be the most majestic and fearsome sight, akin to a living portrait of existence's fragility, where light and shadow intertwine in a final dance. Nevertheless, all these frenzied explosions serve merely as a modest prelude to the true culmination of the cosmos. Once all stars have faded, the universe shall enter a more bizarre phase, inhabited solely by isolated black holes. Black holes, often portrayed as voracious monsters that consume everything, do not actively hunt prey. They may persist tranquilly for trillions of years, drifting like solitary phantoms in the gloom, only occasionally ingesting a fragment of a neutron star or white dwarf as an unexpected morsel. Black holes appear utterly dark because their gravitational pull is so intense that even light cannot escape, yet they are not eternally black. The eminent physicist Stephen Hawking discovered that black holes emit energy through a phenomenon known as Hawking radiation. In simple terms, within the vacuum surrounding a black hole, pairs of particles and antiparticles continually emerge and annihilate. Occasionally, one particle falls into the black hole, whilst the other escapes, carrying away a minuscule portion of energy. This process is exceedingly slow. A supermassive black hole at our galaxy's center requires at least 10 to the power of 100 years to evaporate entirely, vastly exceeding the current age of the universe. For the preponderance of the future, the cosmos shall be a stage for these monotonous, isolated black holes, silently adrift in stillness, evoking a profound sense of solitude. Like an ocean devoid of waves, when the final black hole dissipates, it does not explode violently, but fades gently, without sound or trace, bequeathing a universe of absolute emptiness and complete quiescence. Yet this is not the terminus. The cosmos still harbors fundamental particles, such as protons and electrons, the building blocks of all matter. In the 1970s, Howard Giorgi and Sheldon Glashow investigated the grand unified theory and inferred that protons may decay sluggishly. With a lifespan of at least 10 to the power of 33 years, tens of millions of trillions of years. Although not yet observed, experiments such as Supernovae have established a lower limit on proton lifetime exceeding 10 to the power of 34 years. And the forthcoming hypercamiocondy shall probe even deeper. When the last proton decays, the universe shall lack intact atoms, leaving only dilute radiation, resembling an infinite desert where everything dissolves into nothingness. And then, the vacuum, that which we perceive as empty, is in fact permeated with energy fields. If the current vacuum is false, not the most stable, it could decay at any moment, generating bubbles of true vacuum that expand near the speed of light, rewriting the laws of physics. Scientists such as Sidney Coleman and Frank DeLucia have described this, and research in 2025 has demonstrated that it may be simulated via quantum computers, with bubbles dancing within the false vacuum. For instance, utilizing a quantum annealer with 5,564 qubits, physicists have modeled a one-dimensional false vacuum decay, observing the formation, growth, and interactions of quantized bubbles in real time, revealing how these interactions propel the long-term dynamics of the process. The probability is low, but given infinite time, it may transpire. Thereafter, the old universe is obliterated, potentially birthing a new one, repeating the cycle, as Roger Penrose proposes in his conformal cyclic cosmology, wherein the universe expands and contracts eternally without necessitating a new Big Bang. Recent developments in 2025, including analyses on arXiv and discussions in scientific forums, have explored how gravitational waves facilitate natural transitions between eons and anomalies in the cosmic microwave background, may represent remnants of phantom black holes from prior cycles, bolstering Penrose's framework. Yet if the cosmos exhausts its impetus for renewal, it shall become vacant, frigid, and serene. However, quantum mechanics persists in ceaseless fluctuations at minuscule scales, capable of generating anything from nothingness, even a complete brain endowed with consciousness. Termed a Boltzmann brain, from Ludwig Boltzmann's idea over a century ago. Scientists such as Sean Carroll and Brian Greene discuss that in an infinite future, such brains may outnumber those from evolution, upending our understanding of life. Time itself may lose meaning as change ceases. Recently, in 2025, new calculations indicate that the universe may conclude earlier than anticipated if all entities evaporate via a Hawking-like radiation process. Yet still spanning 10 to the power of 78 years, a colossal figure. These computations suggest that even white dwarfs and neutron stars emit such radiation, accelerating decay, though some critics argue the models are incomplete and the claims overstated. Dark energy may vary over time, as data from the Dark Energy Spectroscopic Instrument imply, potentially leading to a Big Rip if it manifests as phantom energy, tearing asunder all structures. From reputable sources, Neil deGrasse Tyson and Brian Greene have deliberated vacuum decay as a means to avert heat death by transitioning to a lower vacuum state. Notwithstanding, we humans, insignificant with a civilization mere millennia old, possess the intellect to comprehend this, like fortunate spectators at the cosmic performance. It is a gift, stirring emotions about existence, urging us to cherish the present moment. Finally, I extend sincere gratitude to all the scientists mentioned in this exposition, including Subramanian Chandrasekhar for his pioneering contributions to the fate of stars and the Chandrasekhar limit, enabling a deeper understanding of the endings of familiar celestial bodies. Stephen Hawking for discovering Hawking radiation and his profound reflections on black holes and the self-creation of the universe, illuminating the darkest corners of the cosmos. Howard Giagi and Sheldon Glashow for the grand unified theory and predictions of proton decay, opening portals to the instability of fundamental matter. Ludwig Boltzmann for the concept of random fluctuations leading to Boltzmann brains, challenging our thoughts on consciousness and existence. Sean Carroll and Brian Greene for modern analyses of Boltzmann brain paradoxes and vacuum decay, clarifying deep cosmological issues. Roger Penrose for the conformal cyclic cosmology model, offering hope of eternal cycles, along with Albert Einstein for the theory of relativity, Edwin Hubble for discovering the expansion of the universe, and numerous other researchers from the National Aeronautics and Space Administration, the European Space Agency, and groups such as Super Cameo Conde. We honor their persistent efforts and silent dedication to human knowledge, which have illuminated the path of cosmic exploration and inspired countless generations.